Resume recording. Good afternoon, class. Let's have a recap. Nakikita na ba yung screen? Sorry. Okay. Last time, tayo, no? MOSFET. Tapos tinignan natin kung paano yung MOSFET nagiging switch, no? Switch na gawa sa nonlinear element. Okay, kasi yung alam nating switch, usual alam nating switch is the mechanical switch, which requires us to do effort para buksan at patayin. Okay, so recap lang, meron tayong MOSFET na ganito itsura. Ayan, meron drain, source, gate. Si gate yung nagko-control kung may current ba sa drain papunta sa source. Okay? Okay, paano magkakaroon ng current? Kapag si VGS or the gate voltage is greater than the threshold voltage VT. Okay? And then, kapag less than doon, walang dadaloy na current. So, yung ginawa natin dito, this is the switch model. The switch model. Ibig sabihin lang, naging switch yung itsura nung MOSFET mo. Kasi, syempre, paano mo ito i-solve? Wala ka naiintindihan dito. So, gagawin mo siyang mga model. So, unang model would be the switch model, which tells us that the drain to source na current does not see an resistance kapag nag-pass through na siya. And then from the switches, nakagawa tayo ng mga logic gates sa tulad na lang ng inverter dito. The inverter gate. Okay. So binabaliktad niya yung signal mo from high to low and low to high. Kita natin yun. And then you can do more combinations to produce the other kinds of gates like not and yung not or. So paparallel mo sila and so on and so forth. And then a more realistic model comes in. So syempre in real life merong resistance talaga yung MOSFET mo. So kapag nag-on na siya, nare-replace na siya ngayon ng resistor na pagpangalanan nating R-on. Okay. Kanina wire lang siya, di ba? Sa switch model, wire lang siya. And then that, naging ganyan. So we have now the drain to source current as this. So ohms law lang, di ba? Yung drain voltage tapos divided by the resistance for VGS greater than VT as usual. Okay, so now we proceed to a better representation of our MOSFETs. So for this subchapter, well, chapter siya, hindi siya subchapter. MOSFET amplifier yung topic. Pero ang haba nun, ang daming sinasabi. Hindi pa natin kailangan lahat yung ideas na nandun. So, pili lang yung mga didiscuss natin. Wait lang, ang init. Ayun, I'm back. Mamatay na tayo ang init. Global warming. Okay, for this new topic, MOSFET amplifier naman yung pagtutuunan natin ng pansin. Okay. So, yung actual MOSFET characteristics, actual, no? So, hindi na siya mga model. Yung model na natin siya sa legit na itsura niya. So, from last time, alam natin ito, na VDS over IDS is just yung R-on from the SR model. Okay. Ngayon, it turns out that this relation okay, may tanong. Bale, sir, hindi na po namin need aralin yung lahat ng nasa chapter or kailangan pa rin, sir? Magbibigay naman ako ng prob set, so yung mga prob set ay yung mga basis na kailangan yung aralin. Pero yes, hindi na kailangan lahat. Pero it's nice to read. Okay, again, this it turns out that this relation is only valid for this relation. So pag yung voltage mo sa drain is less than the VGS minus VT, the gate minus the threshold. Okay. What happens if you exceed this value? So pag ginraf mo yung nagkabit ka ng mga ammeter at voltmeter sa MOSFET mo, you can see that if you try to increase the voltage sa drain, this would happen. Okay? Magiging non-linear na siya. Linear lang siya doon sa triode region or yung itong relationship na ito. Okay? So this is called the triode region. Triode yung unang pangalan ng mga resistor. Okay, so triode region. Ay, kaya siya pa nangalanan na ganyan. Wala lang. Ni ano lang yan, nomenclature lang. Nothing special. Okay, for this region, nagiging linear ka. Ibig sabihin, may ganitong relationship yung IDS and VDS mo. Okay, ito yan. Walang bago. However, at this point, meron tayong tinatawag na saturation region. Ibig sabihin, for that part, yung current mo hindi na tumataas or minimal na lang yung pagtaas as you increase the voltage in the drain. Okay? So yung saturation region, you can obtain that by using this relation. Siyempre, kailangan mo muna yung para may current ka, kailangan VGS greater than VT, di ba? Ayun yung unang-unang natin. Para naka-on yung MOSFET. And then, you have this new relation that dapat VDS is greater than VGS minus VT para makapag-operate ka sa saturation region. Okay? Makikita natin bakit natin gusto mag-operate sa saturation region. Yeah. Alright. Okay. So with that, let's have a better representation of the MOSFET. So ito ay yung switch current source model. So switch tapos current source. So switch dahil nakapatay. Then pag binuksan mo, magiging current source na siya. Dependent current source. Okay? So yung current source, it would have this characteristic. So IDS must be equal to K, some constant K, nasa properties ng MOSFET, then times the gate voltage minus VT squared. Valid when VDS must be greater than VGS minus VT. So saturation siya, valid. Alright. So kapag nasa triode model ka, gagamitin mo SR model. Okay? Kapag nasa triode region ka, SR model gagamitin mo. Kapag nasa saturation region, itong switch current source gagamitin mo. Okay? Pansinin na yung current mo is a function of VT is constant, di ba? So function of VGS siya. Tapos squared. So quadratic yung itsura niya. Hindi ko nalagay yung graph. Sige. Drawing natin. So, kapag yung IDS versus VGS yung VDS, yung ginraf mo, VGS na. Parang weird yung ano. Okay lang pala. Sige. Teka, kopyahin ko na nga lang yung ano. itsura ng graph. Kainis. Yan, okay. Okay, so dahil squared yung relationship, you can have this kind of BGS yung graph natin. Parang tayo mahirapan sa buhay. You have this kind of relation dahil ito ay quadratic. Okay? So, K BGS VT squared over 2. Okay. Wala lang. Visualization lang. Tapos yung kapag in terms of VDS naman, ganito siya. Okay. So in mathematical terms, ito yung itsura niya. Okay, kapag less than yung as usual, less than threshold voltage yung VGS mo, walang current na dadaloy. And then kapag nasatisfy mo yung may dadaloy, then yung saturation region, makukuha mo yung ganitong quadratic na current. Okay? Now, ito na yung main event nung MOSFET amplifier. Kung titingnan nyo, ganun pa rin yung itsura ng circuit, di ba? Again, para doon sa mga nalalabuan, ano yung symbol na to? This only means that naka-connect siya sa isang voltage source na pangalan VS, tapos nakakabit siya sa ground. Pero pagod tayong mag-drawing, so yan. Diba? So, ganyan, gamitin natin. Mas maikli. Alright, okay. Ngayon, pinangalanan lang natin yung iba't ibang bagay as input-output para malaman natin yung relationship nila with each other. Okay? Pwede naman natin pangalanan ng VDS, VGS, and so on. Pero mas maganda na input-output yung gawin natin para makita natin kung paano yung amplification. Okay, KCL ako dito. KCL ako dito. By KCL, I know that Vs minus V0 over RL must be equal to, magiging current source to pag nakabukas, di ba? So, may current siya na pinaproduce or coming out would be yung I, Bs. Okay? So, V0 must be equal to Bs minus I, Bs RL. Okay? Okay. So, with this, Bs is given. I know my IDS to be some function K over 2. Then, V in. So, si V in na kasi nasa gate, di ba? So, si gate na yung V in. Therefore, siya na yung V in. Papalit siya. Then, Vt has to be in the properties of my MOSFET. So, given si Vt, given si Vs, given si RL. Okay. Given si V in, and so on. So, you have this relation. And then, with this, we can see that V, if we divide VO by VIN, then you get so dinivide lang natin. Nothing special. Dinivide mo siya. And this guy, here is the amplification that you will get. Okay. So, kung i-graph mo naman si DO with respect to Vin, so yung relationship mo ay quadratic pa rin pero negative. So, negative Vin squared yan. Then graph it something like this. Okay. And as you can see, for inputs that are somewhere here, your input is amplified. Okay, kasi mababa yung input mo, tas mataas yung output mo. Okay, dapat napansin na natin yan nung ano pa lang, nung sa switch pa lang, yung inverter. Napansin natin, ini-invert niya yung low to high. Okay, so that signals na MOSFET can be used as an amplifier. Sir, bakit hindi naman na lang diretso kung ano? Hindi mo na lang idiretso yung ano, yung VO. Ba't ko pa kailangan mag-amplifier? Pwede ko naman rektahan ng something na voltage divider dito para magamit ko si VS to get my desired output, no? Ba't hindi ganun, no? Usually kasi itong system na ganito, ito ay external. So, kuwari ito ay chismis. So, syempre hindi manggagaling sa yung chismis, no? Manggagaling sa iba yung chismis. So, kung gusto mo i-amplify yung chismis, papadaanin mo siya sa amplifier. Okay? Okay. So, ayun. Wala namang bago. Wala namang bago sa kanya. But let's try an example. Okay, so ito. Magulo na yung circuit mo. Gusto natin malaman yung input-output behavior ng amplifier na to. And titignan natin kung saan yung range ng Vin so that yung MOSFET mo remains in the saturation region. So yung mga example sa libro, puro ganito. You're just gonna check if it is in the triode region or in the saturation region. Kasi yung mathematical part niya napakadali lang, di ba? Walang bago. Okay, so given this specs, so Vt is equal to 1 and then K is equal to 1, then milliampere nga lang over voltage squared, volt squared. Okay, let's try to understand this circuit. Okay, magtanong tayo. Si Erin, nandiyan ba si Erin? Right there.
Yes po, sir.
Okay, ano yung VB? Solve mo yung VB.
Pwede pong patingin ng notes kanina.
Hindi mo kailangan ng notes kanina para makuha si VB. From chapter 2, ano to? From chapter 2 topics to para makuha yung VB.
Ay, okay po, sir. Sir, ino-node analysis po siya.
Pwede. Pero parang overkill yung node analysis din.
Evo voltage divider po, sir.
Okay, sige. Ano yung voltage divider?
10 volts times
10 volts?
16.
Okay. Wait lang. Sulat ko. Times
16 po.
16 lang?
Over 16 kilo ohms. 16,000 ohms po ba?
Okay.
Over 100 po yun.
100,000
ohms po.
Okay. So, ano sagot dito? This is, anong sagot? Ikaw pa rin, ha?
Sir, ano po? Over 1.6.
Okay, very good. Sige, bonus na. Bonus. Diba? Okay, so may 1.6 tayo na VB. Okay, what else can we obtain from this circuit? Okay, sinong gustong sumagot? Sino gustong sumagot? Parang hindi ko pa bibigyan yung tanong, syempre. Baka lang may gustong sumagot para naman sa bonus. Madali lang naman, mag-node analysis ka lang. Node analysis yung next na tanong. Okay, wala. Sige. Sayang. Tatanong ako random. Si Joshua. Diyan ka ba, Joshua? Okay, wala. Okay. Sino gusto? Walang may gusto. Madali lang to 5 points agad. Kalahating tanong ng isang subject. Okay, sige, sayang. Ako na lang magsasagot. Okay. Hanapin natin yung voltage V out. Mag-node analysis tayo dito sa node na to. This node. Okay. At that node, the incoming current is given by Vs minus V out over R3. That must be equal to IDS. Tama. Oh, kanina lang din. Okay, but I need my V out. So V out has to be Vs minus IDS R3. Okay, and then IDS okay, tama. IDS is just yung relationship natin for the MOSFET. So that would be VGS minus VT squared. Tama? And then what is VGS in our case? VGS is this arm minus this arm. So VGS must be VB minus Vin. Okay, bakit si VB? Kasi si VB is measured with respect to the ground naman. Okay, we have that. Walang bago, di ba? Dali lang. And then this is VB minus Vin minus VT squared. So this is V out. VO. V out pala. Nakalito talaga yung notation ni Agarwal. Okay, so we have this relation. If we are to plug in the values that we have, this would result to 10 minus 10 times 0.6 minus Vn squared. Okay, so we have this relation. Now, next would be, kailangan natin malaman kung ano yung relationship natin for the saturation region. Okay, so recall ano yung saturation region natin. VDS must be greater than VGS minus VT. Okay, so dagdagan pa natin ng dagdagan pa natin ng inequality. Alam natin na si VGS required natin na must be greater than VT. Therefore, pag nilipat ko yan, VGS minus VT greater than 0. So therefore, I can write, kukonektahan ko to 0. Okay, so this is what we need. Then we plug in the things that we have. Okay. Now, what is VDS? Balik tayo. VDS must be V out minus V in. Okay? V out minus V in. So, this is V out minus V in. And then, greater than equal to. VGS is, nakuha na natin to kanina. VB minus V in. VB minus V in greater than 0. Okay, so we have this, may minus T. VT pa pala. Minus VT there. Sorry. Okay, with this relationship, tinatanong sa atin kung ano raw yung ranges ng V in so that the MOSFET remains in the saturation region. Okay, so with that, so pwede po paulit kung bakit naging VB minus V in yung VGS. Okay. Ano yung voltage dito? Di ba V in agad siya? Tapos ito ground kasi. Ground itong mga to. Ground yung nasa ilalim. Well, I can choose it to be the ground for simplicity. Okay, V in agad ito. Tapos, anong node voltage dito? VB? VB ito, di ba? VB naman ito. Tapos si VGS kasi measured siya with respect to the two lower arms of the MOSFET. Okay? So, minus mo lang kung ano yung voltage dito, tapos minus mo siya dito. So, VB minus Vin. Okay? Okay. Okay, going back. Ano nangyayari? Kailangan natin mahanap si Vin na... Okay. So, gamitin natin yung una. Gamitin natin itong side na to. Gamitin natin itong side na to. What does this give us? So, VB, na-compute na natin siya kanina, 1.6. Tapos, given yung VT na 1 minus Vin, 0. And 1.6 minus 1, that's 0.6 minus Vin. Therefore, Vin must be less than 0.6. Okay? So, lipat mo lang si Vin. Mas binaliktad ko lang naman. 0.6 greater than Vin. Okay? So, ganito rin yun. Baliktarin mo lang. Okay, so nakuha na natin yung upper bound ng Vin. Hanapin naman natin yung lower bound. So, next naman would be, gagamitin ko to. Okay. With this, magagamit ko na V out minus V in greater than VB minus, patong na natin. Alam ko naman na 0.6 siya. 6 minus V in. Okay, this cancels out. V out must be greater than or equal to 0.6. And then I have here my V out. do this. So I can solve that. 10 minus 10.6 minus V in squared greater than or equal to 0.6. And algebra. So ayusin nyo lang. Turns out you can find that V in must be greater than. Negative 0.3695. Okay, now we have our ranges for V in. So V in must be less than 0.6 and must be greater than negative 0.3695. So when this input is satisfied, our MOSFET remains in the saturation region. Okay? Consequently, pwede mo hanapin yung ranges din ng Vout. So yung Vout na makukuha mo when operating in the MOSFET region can be obtained by yung relation natin kanina, 0.6 minus V in squared. So you plug in your values. Plug in natin si 0.6, you get V in 0.6. It's easy. 0.6 minus 0.6, that's 0. So V out is 10. Then at V in equal to, so pina-plug in ko lang yung boundaries ng yung V in ko. Wala namang bago. 0.3695. Sir, quadratic. Ito ba yun tinatanong mo? Quadratic ba to? Ang mangyayari dito pag inayos mo to, hindi ka gagamit ng tawag dito. So 0.6 minus V in squared greater than 6 minus 10 divided by negative 10. Okay, so square root mo, mas malalabas mo si V in ng normalan. Okay, then from there, malalaman mo yung, sige, tingnan natin. Okay. No, bother ako sa negative sign, so iaangat ko siya. Okay, much better. Is good. Okay, this is always a positive number, therefore yung positive kukunin mo dito. Okay? Tama ba? So 0.6 minus V in. Well, may ganito pa. But you already know V in must be less than 0.6. V in must be less than 0.6. So this is always positive. So no need for absolute value. And you can solve this. Kaya nyo na to. Okay? Okay. So paano siya kukunin? Kung anong root pipiliin, gawin mo siya, malalaman mo kung alin yung mag-make sense physically. So walang general rule no? Walang general rule. You just have to do it. Okay, going back at negative 0.3695, you plug in that to your value and you will obtain V out to be 0.600009 something. Okay, basically 0.6 volts. Therefore, V out runs from 0.6 V out 10. Okay? Okay, so that's it for that example. Alright. Now, hindi pa tayo tapos. Let's proceed to, again, maraming pang topics in the chapter involving MOSFET amplifier. Pero I think overkill pa yun para sa atin. So we won't go for it for now. So let's proceed to the next chapter, which is the small signal model. The small signal model, ito yung implication nung pag-aaral natin ng nonlinear analysis from chapter 4, yung incremental analysis. So meron siyang implications, and that is small signal model. Basically, you would, para mas papadali lalo buhay natin, mapalitan natin yung iba't ibang circuit elements natin kapag merong small signals, kung small signals ang ititignan natin. Okay? So, ito, meron tayong small signal circuit representation. Okay. Kuwari, MOSFET mo, kapag large signals yung ginagamit, you have to use this representation. And then, kapag small signals na yung ginagamit mo, you can use this representation. Okay, ito saan to nakuha? Nakuha to doon sa yung dinederivative natin. Diba, IDS is the derivative of F of BGS over BGS evaluated at VGS times BGS. Okay? So, walang bago. Ito yung last time. Ito pa rin yung last time. At small signals, operating at small signals, you have this, papalitan mo siya ngayon ng yung current source niya. Papalitan mo ng ganitong relationship. Okay. Sa resistor, walang nangyayaring bago. Walang nangyayaring bago. Resistor is resistor. Wala siyang, hindi siya tinatablan ng mga time-changing values. Resistor pa rin siya. Okay, for the voltage source na DC, okay, DC itong mga to, malalaking mga letra, no? DC. Ang gagawin mo, pag tinitingnan mo na yung mga small signals, you can turn it off or make it a short circuit. Okay. And then for the current source, as expected, magiging open circuit siya. So DC to, DC na current source ito. Tapos for a general nonlinear element, given this, okay, kuwari yung characteristics niya is current that is dependent on the voltage applied to it. Then, para maging small signal yung niya, para makita yung small signal effects niya, okay, this is from chapter 4. You just derivative it, then you plug in the operating value or the bias voltages. In the similar way, kung kabaliktaran naman yung binigay sa'yo, the voltage through a nonlinear element is dependent on the current applied to it, then you can get this relation. Okay? Okay. So yan, let's try this example. Yung drain nakakonect sa gate ng yung drain nakakonect sa gate ng tawag dito. MOSFET. Okay. Sorry, nawala na ako. Okay. In some sense, palitan mo to ng dependent current source going down. this and IDS must be given as yung usual mo na VDS na to. Kasi VGS is same as VDS. Okay, minus VT squared over 2, provided that VDS equal to VGS, that is both greater than VT, para mag-operate siya. Okay, from this, kung small signal yung titignan mo, you can replace it with something like this. Magiging IDS na siya. Palitan natin kasi small signal tayo. So, ito ay magiging VDS minus V. Okay. And then, yeah, ito na siya. So, this is, hindi ko alam kung tama ba to. Tama siya, pero I mean, is it a good way of doing that? Teka. Okay, tama naman. Okay, so tingnan nyo maigi to. Ito ay current, ito ay, sige, expand natin para mas makita natin. BS, ay sorry. KVDS, ay. Dapat small to, no? Small, para ang time ito. KVDS minus KVT. Ay, oo, galing. Ano ko dun. Tama. Sorry. Nakamukha kasi mga letra. Okay, so ito ay derivative ng... Teka, sino yung nag-comment? Okay, bonus. Wait lang. Record lang ako. Ito ay... Okay. So, derivative natin, di ba? Tapos, VDS minus VT. Tapos, mawawala na yung 2 kasi, yung over 2 kasi bababa siya dahil sa derivative. Evaluated at VDS equal to capital DS and times V small ds. Okay, so ganito. So IDS is just equal to K times capital V ds minus VT times V ds. Okay, what's nice here is that this is all constants. Constants ito. Constants. And if we would rearrange things, this would look like 1 over K VDS minus DT times IDS. Okay, V is equal to IR. So, pwede mo itong isipin as resistors. And then for small signals, this could actually become a resistor. And this is the SR model. Okay? Babalik ka dun sa SR model kapag small signals ka. It's nice, no? It's nice. Okay, let's try it with a more general example. Let's have here the MOSFET amplifier. Okay, given ka ng VI na input. So, V capital I ito, no? So, VI can be made into something like this plus a small signal VI. Okay, so ito ay galing sa chapter 4, walang bago. Okay. So first thing that you will do for small signal analysis, for the incremental analysis, is to get the operating point values. Ibig sabihin nun, doon ka sa mga large values mo. Okay. So with this, itong circuit ko, itatransform ko muna such that everything is in the large values. So VI becomes capital VI dahil nga ganito. And then VS, yung katuloy nito, di ba may source dyan? So capital VS. Okay. So si VS naman ay constant, so VS lang talaga siya. And then this implies that by KCL at this node, VS minus, as usual, V0 over RL must be equal to the ID. Okay. And then VO becomes VS minus ID RL. Okay, ID is ito. Plug in mo lang tong value na to. Tapos yung gate voltage mo ay given nung voltage dito, which is naka-bias voltage siya. So yung malaking voltage yung ginagamit. Okay, so we have these values. Okay, so may output ka na ganitong malaki. And then, now you go for the small signal circuit representation. So what you will do is patayin mo yung mga DC na voltage source mo or current source kung meron. So for this case, voltage source yung meron sa atin. So I turn this off. Okay, I turn this off. And then I replace this with a small signal circuit representation. Okay, so the derivative ko siya, ito yung lalabas. Okay. So now, napalitan na yung source ko dito ng V small I dahil siya ay small signals na lang. Okay? Okay. So from here, KCL ako at this node. So V. So ganun yung i-assume kong current. Okay, V0 VO minus 0 dahil ground RL must be equal to the negative of ID. Therefore, this is negative K capital VI minus VT and then VI small VI. Okay. Okay, so that's that. And then simply, I can get VO to be negative KRL VI minus VT VI. Okay? Okay, nice. Kunin natin yung small output voltage. Therefore, your total voltage is just your capital plus the small signal. It's nice. Okay, and then let's have next time na yung ibang examples pa. Kino-curate ko pa examples from the book. Hindi ko alam kung ready na kayo mag-amplifiers and such. Okay. Proceed tayo with some terminologies lang para hindi tayo ma-lost somewhere. Okay, so ito ay input and output resistance, current, and power gain. Dapat, okay, tama pala. Current gain tsaka power gain yun. Kaya walang Oxford comma. Okay, input resistance, Ri, is the incremental So, siya yung incremental input resistance. Ba't walang turbo? The change in the input current for a small change in the output voltage. Okay, so kuwari dito sa circuit na ito, let's analyze this. Sorry. Okay. So input current, change in the input current for a small change in the Sir, yung small signal representation, applicable din po ba para sa MOSFET switch? Yes, ito MOSFET itong ginagamit natin. Switch pa rin naman to. Lagi lang tayo nag-assume ng VGS greater than VT. Ay, VT. Switch pa rin to. Wala naman tayo ma-obtain na something kapag VGS less than VT. Kasi zero na lang siya. Tapos wala na current. Putol na yung circuit. Putol na yung circuit mo. Okay, so tuloy tayo. Input resistance. Change in input current for a small change in the input voltage. So Ri must be equal to V test. Okay, or V in. Tapos I test. Or input na current at input na voltage. So bakit test yung ganun sa kanila? Yung test yung ginamit mo sa kanila. Kasi you want to just input a little bit of voltage or a little bit of current. So kaya test lang. Testing ka lang ng maliit na current. Okay, for this part, so pag naglagay ako ng V-test and then meron siyang produce na I-test, yun na natin. So Ri, for this case, is V-test, I-test, and then I-test is 0 kasi walang dumadaloy na current sa gate. Zero. So this is infinite. Infinite yung Ri mo. Okay. Dali lang, di ba? Input resistance. Output resistance naman, change in the output current for a small change in the output voltage. So our out is okay. V, ganun pa rin, V test pa rin. Pero lalagay mo nga lang siya sa output terminals mo. Okay, so magka-testing ka sa output terminals mo. So from here, naglagay tayo ng source na testing lang natin. Kung ano ba yung output resistance here. Okay, so V test over I test. Yung kung dito rin yung output mo, di ba? Same wire lang yan. Okay. So what is the voltage difference there? V test must be okay. Pansinin nyo dito sa kabila, walang nakalagay. No? So walang current na dadaloy dito. So yung current mo, pa ganun lang siya. Okay. So yung circuit mo, pinapatay mo muna siya tapos saka ka magta-testing. Then V test must be equal to I test RL. Okay, so pag dinivide ko to by I test everything, I could get my R out. So R out is equal to RL. Okay, terminologies. Next is the current gain, is the incremental current gain. So the change in the output current divided by the change in the input current for a given external load resistance. So merong ganito. So maglalagay ka ng load doon sa output. So try natin. Sulat muna natin yung gain natin. Current gain. Yes. Sobra sa R. Sobra sa R. Gain. Okay. Current gain is equal to I output over I test. Okay. So, magte-testing ako sa input, titingnan ko ngayon yung output. So, for this part, let's try to analyze this. So, nag-input ako ng test current. Okay. So, hindi na zero yung test current ko dito kasi merong resistor dito. Okay. And then, kunin ko si I test. I test is simply V over R. V over R dito. So V test over Ri. Okay, Ri. And then ito yung sinasabing external load. So sa output terminals mo, lalagay ka ng external load resistance. So RO. And then let's get that voltage. Okay. So VO is IO na lang. So IO must be equal to VO RO. Tama ba? Nope. Mali. Actually, tama. Tama. Double checking lang. So with that, the current gain is V O over R O tapos divided by V test over Ri. And this is just VO over V test tapos multiplied by Ri RO. Okay, tama. So, ayan yung current gain mo. But let's try to find out ano yung VO and V test. Okay. So, VO okay, madali lang. Alam natin may dumadaloy na ID na current dito. Okay. Tapos, so natin malaman yung VO here. Therefore, using the KCL over there, VO must be VO minus 0. Tinitingnan ko pa ganito, no? VO minus 0 over RL parallel with RO. Okay, RL parallel with RO. And that must be equal to a negative. Napangit tayo pala ng ganito. Oh no. Okay, ayaw niya. Lahat ay outward, so this is IBS. Or ID in that case. ID. 0. Okay, KCL lang ako. Bakit ganun? Kasi lahat ay outward. So, nag-assume ako ng current directions sa ganyan. Okay, weird na convention, but it works. So, with this, I have VO to be I negative ID, then parallel with RL, RO, and then ID comes in as this guy, KVI minus VT. Okay, VI minus VT, V test. Tapos, RL parallel with RO. Hindi natin breakdown yung parallel, no? So, therefore, VO, V test is just negative K VI minus VT, and then RL parallel with R0. Okay. So, that's your current gain explicitly. Pa-plug in mo lang to doon. Current gain. Okay. Tapos nakuha mo rin yung voltage gain. No? Nakuha na natin yung voltage gain. So, this is the voltage gain. Okay. And then lastly, the power gain. Okay, incremental power gain. So, ratio ng power supplied to an external load tsaka yung input sa source. Okay. Input source. So, P gain is just VI, di ba? So, sa output tapos sa input. I test. Okay? So, for this circuit again, alam natin si IO saka si I test. Nakuha natin siya. IO, I test. And then, VO, V test. Nakuha rin natin. So, VO, V test times IO, I test. So, that's VO, V test times RI over RO. Okay, that tells me na naka-square ito. Kunin lang natin to. Square lang natin tong bagay na to. So, K VI minus VT parallel ng RL at RO. Tapos, naka-square. And then, RI times RO. Okay. Charan. Ayun na siya. So, wala nang negative, no? Kasi may square naman. Ganun din. Ayun lang. Terminologies lang naman siya. Kasi minsan tinatanong, what is the power gain? Blah, 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 blah. Ganun. Okay, so that concludes our lesson for today. Tapos na tayo sa lesson ng magbibigay naman ako ng mga examples further. Okay? So exam walang pa boses ko. Exam nyo would be next week again. Okay, but wag muna natin isipin yan. Ano lang naman, target date lang naman siya. What do you call this? Let's do the design experiment kahapon. Let's do the design experiment kahapon. So, reading break po ata next week. Edi bago mag-reading break, mag-exam tayo. Kesa after reading break, di ba? Hindi nyo ma-enjoy yung reading break kapag nag-aral lang din kayo sa reading break. Okay, sa mga gusto na mag-leave, okay lang. Okay lang, no? Time naman na. Well, in 12, 13 minutes. But I will have to discuss yung design experiment natin na kahapon. And makikita nyo kung bakit siya mas madali from the experiment ng lab activity number 2. Okay, let's do this. So first things first, gagawa tayo ng, meron akong, so yung device, specs of com device, 5 buttons, 2, 5 LEDs are used to communicate. Okay. Tapos may specific na combinations yung communications device na gusto kong gayahin. But syempre, as a start for all devices that you are making, you have to make your device operational. So first things first is that you dapat gumagana yung mga bagay-bagay. Okay. Ground tayo. 5-volt source. Okay. Ground. Then I'll make a long line here. So yan ay 5 volts lahat. So kakabit na lang ako dyan kapag gusto ko. And then I have buttons. Kabitan ko siya. 1, 2, 3, 4, and 5. Okay. And then this, this, this. Okay. And then I could make a diode here. I could connect a diode here. Pero ang problema ko sa ganitong configuration, 5 volts yung 5 volts yung dadaloy sa diode ko. And kapag gano'n nangyari, pag 5 volts to, ano yung kailangan mo ilagay dito para maging, pag 0 nilagay mo dito or anything that is less than 5 volts, so diode is on. Diode is on. Okay, so dapat alam nyo na to guys, no? Dapat from the second, the second activity pa lang, alam nyo na dapat to. Tapos kapag 5 volts, pinabitan ko siya ng something that is greater than 5 volts, diode is off. As simple as that. Okay. However, from this experiment, 5 volts, kung 5 volts na ilalagay ko dito, wala na akong magagawa para mapatay siya unless babalik ta rin ko ng buong diode ko. Okay, so wala na akong paghuhugutan ng greater than 5 volts eh. So dito hindi naman pwede kasi 5 volts lang din and baka masira pa yung circuit ko. Okay, mag-short siya. Okay, so I won't do that. I will replace this as resistors muna. Resistors. So equal ko lang to lahat ng resistor ko para simple yung model ko. Diode. Diode, diode. And then pwede pa ako maglagay ng extra resistors. Kasi this wouldn't affect my LEDs, but just to make the circuit safe. Ground, 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 ground. Alright, so lahat na ngayon ng diodes ko operational. If I press this button, ilaw to. If I press this button, ilaw yung pangalawa. Yung pangalawa. 1, 2, 3, 4, 5. Okay, so gagana sila lahat, no? And I know that this is from the level here, this is 5 volts. This is less than 5 volts. And this is less than 5 volts. This is 0 volts. Okay? Now, yung communication device, I know that first things first, wala akong pinindot, walang ilaw. That's true. Wala akong pinindot, walang ilaw. The second clue that I have is kapag pinindot lahat, ang mangyayari is that yung tatlo lang sa gitna iilaw. Okay? And then mamamatay yung dalawa. Mamamatay yung dalawa sa gilid. So, say 1 at 5, mamamatay. Okay. From that, ang daming possible na pwede kong gawin, no? I could turn off 1 and 5 by using one switch. Okay, so may 3 choices ako for that switch and so on and so forth. Pero ang arbitrary lang naman yung gagawin ko. So, piliin ko na lang si 4 tsaka si 2 kasi malapit sila. Tipid sa wire. Okay. So, ito alam kong 5 volts to. Yung unang wire, 5 volts. Kukonect ako ngayon yan. Connect ako sa dulo. Okay. And then, connect ako rin to dito. Okay, if I press my 4, ano mangyayari dito? 5 volts na to. So, 5 volts to, tapos less than 5 volts to. Ano mangyayari dito sa LED na to? Mamamatay. Therefore, if I press everything, ito, gagana as usual, gagana as usual, gagana as usual. Ito, mamamatay kasi 5 volts yung sinusupply sa kanya dito. Tapos yung nandito sa kanya sa kabila, less than 5 volts. Okay? Okay. Now, if I, by doing this, naging flexible yung circuit ko kasi pwede kong pindutin si 5, iilaw pa rin to. Okay. Pinindot ko si 1, iilaw pa rin to. Pinindot ko si 2, iilaw pa rin to. 3, ilaw siya. 4, ilaw siya. So wala pa kasi ako idea about the clues that I have. The only clue that I have is that when everything is pressed, only 2, 3, and 4 will light up. Okay. So now, sige, chat kayo. Anong gusto nyong malaman na Anong gusto nyong malaman na configuration? Buhayin ulit natin yung Arduino. So, sige, anyone, chat lang kayo. Yan, daming chat. Okay. Okay. So, unang nag-chat, 1, 2, 5 yung pipindutin. Kapag 1, 2, and 5 yung pinindot, patay natin yung virtual background so that you can see. Yeah. Kapag si 1 and 2 and 5 yung pinindot, iilaw si 1, 2, 3, and 5. Okay, so let's write that down. Kapag si clue number 1, config 1. So may nalaman akong clue about that machine na kailangan kong kopyahin. And that is when 1, 2, 5 switches are on. So 1, 2, patay si 3 at 4, 5. Ang ipoproduce niya dapat 1, 2, 3, 1, 1, 1, 0, 1. Okay, so si first 3, open yung bulb. Then si last ay open yung ilaw. Okay. So si 2, kaya kong pindutin nang walang hassle. Pero pag pinindot ko si 2, sure nang mamamatay si 1. Okay, sure nang mamamatay si 1. And we don't want that. So I guess I would switch my wire. Lipat ko siya ngayon. Yung dependence na ililipat ko sa 3. Okay? Kasi wala pa namang silbi si 3 ngayon kasi 1, 2, 5 yung kailangan kong pindutin. Okay, so nakatalon siya kay 2. Hindi siya nakadikit kay 2. Okay, so I press 2, it opens. I press 1, it opens also. And then, lastly, si 5, pag pinrest ko daw siya, so 1, 2, 5, pag pinrest ko lahat, iilaw yung 1, 2, and 3, and 5. So, pwede kong gawin ay yung dependence ng 5, dalawa yung mabubuksan niya. Okay, pwede ko rin naman gamitin si 2 para mabuksan si 3. Okay, arbitrary choice lang. Arbitrary choice lang itong ginagawa ko. Ang mahalaga kasi pag pinutin mo si 1 and 2, dapat bubukas yung mga kailangan mo. So, si 3 din nakabukas. Ang gagawin ko, si 3, yung dependence niya ay sa dependence niya would be coming from 5. So, I could use this. Okay. So, pag pinindot ko si 5, dalawa yung isusupply niya. 5 will be opening this guy. And then, opening this guy. Okay, kaso, may problema pala ako dito. May problema ako dito. When I do this, mapansin ninyo, si 5, nakakabit siya sa dulo ng 1. So, mamamatay tawag dito, 1 kapag pinindot ko rin si 5. So, mali to. So, trial and error ka lang, guys. Okay. Yan. Okay, so we have to configure it in such a way that hindi ko maapektuhan si 1. Okay. Alright, tuloy tayo. What else can I do? Okay, ang pwede kong gawin is that since this is 5, nilagay ko yung 5 dito. Okay, hindi talaga iilaw to, no? So, ang pwede kong gawin is that I could use this line para less than 5 volts yung isusupply ko. Okay. Let's use this line. Kanino papunta? So, 1, 2. Papunta dito. Okay, now, this is less than 5 volts. Dadaloy siya dito, dadaloy din siya dito. Less than 5 volts, tapos less than 5 volts ulit. Punta ako dito. And kapag pinindot ko to, so less than 5 volts na yung makukuha ko kasi ilang resistors din na alam ko. 1. Okay, so less than yung makukuha ko. Okay? Okay. So, ganun. Ayun yung purpose yung sinasabi ko na may resistor ka dapat para mas marami yung choices mo ng voltage. Okay, just double checking. Okay, so 1. Pag pinuksan ko si 5, 1, 2. Okay, 2 resistors yung dinadaan ako. Bale, dito, less than 5 na siya. Dito, less than 5. So, therefore, less than 5, less than 5. Therefore, it's on. Okay? Kahit pindutin ko silang sabay. Alright. Will I satisfy again the voltage kapag pinindot ko lahat ng sabay-sabay? Pag pinindot ko lahat ng sabay-sabay, press ko si 1, press ko si 2, 3, 4, 5. 3 will always turn off 1. And then 4 will turn off 5. Okay? 4 will turn off 5. Then dito walang problema. Yung pagpunta dun ng wire. Napansin nyo? Kasi pag pinindot ko si 3 and 5 sabay, ang mangyayari lang, same voltage at these levels. Pero yun nga, papatayin mo naman siya ng 4. Which is okay. Okay? 3 and 4 and 5, hindi naman sila countered yet sa dulo. So, wala pang mangyayari sa kanila. Sir, paano po yung dalawang resistor dadaanan? Pwede bumalik, sir, yung daloy? Saan-saan? Kasi trace the path. Saan-saan? 5, 3, 1. So, 5, 3, 2, 1. Ito, 5, 3, 1. Anong gusto mo itanong? Sorry. Pwedeng bumalik yung daloy. So, pag pinindot mo si 1, so this is less than 5, dadaloy dito. Then less than 5. Hindi ko gets yung tanong mo. Okay, pakilinaw yung tanong. Okay. So tuloy tayo sa, okay, so this answers my question. This answers config 1, config 2. Maybe let's choose. Okay, 1 and 5. Kapag pinindot ko si 1 and 5, what do I get? Pressing 1 and 5 gives me 1, 3, and 5 on. 1, 3, and 5 yung on. 1, 0, 1, 0. Okay, let's try to press 1 and 5. Tingnan natin kung nasagot na ba yung tanong natin dyan. Pag pinress natin to, okay. So, press ko to. Okay. Makikita nyo na yung 5 will still open the light. Will still open the light for 3. Okay. And then, dito, okay, this is, lagyan natin ang analysis. This is less than 5. This is less than 5. Less than 5. Tapos, this is a wire. So, this is less than 5. And this is less than 5. So, there's a current na pa ganito. Meron din current na pa ganito. So, yung resistor here will just dissipate the power. Will just dissipate power coming from this guy. And as life goes on for 3. So, bubukas yung 3. Bubukas yung 3. Okay, another one. Let's have a new configuration. Okay, 3, 4, and 5. Open 3, 4, and 5. Config 3. Config So 3, 4, and 5. 3, 4, and 5. And that gives me pag 3, 4, and 5, 3 and 4 nakabukas. So 0, 0, 0, 0, 0, 1, 1, 0. Okay. So opening 4, 3, 4, and 5, 3. So burahin natin yung mga analysis natin so that we are in-open ko si 3, this is 5, this is less than 5, this lights up, 4, ang mangyayari, this is 5, this is 5, this won't light up, and life goes on for resistor, switch 4. Okay, nakuha natin. Let's have another one. Okay, parang yun na lahat yung Okay, yung technique dito, since alam mo yung a good choice here is not kung pipili ka ng isang button na ipe-press lang, yung grade mo nun would be by chance. Okay, kasi hindi mo alam kung pag pindot mo ng isa, maapektuhan ba lahat or isa lang din maapektuhan and so on. So a strategic way to do this is you're coming from all the buttons pressed. That gives me 0, 1, 1, 1, 0. So, ang gawin mo, minimal change ka lang. Apat yung pipindutin mo, di ba? Apat yung pindutin mo. Sabihin natin 1, 2, 4, 5. Okay, 1, 2, 4, 5 gives me 1, 2, 4, 5. Binibigay niya sa akin 1, 1, 1, 0. So, from this, makikita mo yung relationship ng mga bagay-bagay. Okay? Okay. So, from 1, 2, 3, 4, 5, alam mo, coming from this, napunta ka dito. So, mapapansin mo that your 3 opens, yung absence ng 3 opens up 1. Okay, so, may isang connection ka agad na magagawa agad for certain. That's an easy grade siya, easy grade. Okay, now you need to find out kung sino pumapatay ng last resistor. So, you grab another configuration. 4 ulit piliin mo para mas madali. 3, 4, 0. Yung 1, 2, 3, 4, 0, gives me 0, 1, 1, 1, 0. So, same lang. Ibig sabihin, madali buhay mo nito pag ginawa mo siya. Kasi same lang yung nangyayari. So, 5 doesn't affect. Turning on and off 5 doesn't affect the circuitry. So, therefore, somewhere between 2, 1, 2, and 4, 1, 2, and 4 controls number 5 light. Okay. And this is nice, no? Kasi kung nakuha mo na tong result na to, madali kang makapunta sa ganitong result. May extra grade ka na agad. And then lastly, pili ka ng other 3, 4, 5. 3, 4, 5. This opens up 0, 1, 2, 3, 1, 3, 4, 0, 0, 1, 1, 0. Okay. From here, okay. So, alam mo, from here to there, na if you turn off 2, napansin mo kanina, turning off 5, walang mangyayari. So, si 5 wala siyang kinalaman dito sa... Si 5 wala siyang kinalaman dito. Okay. Si 3 and 4, hindi yung panagalaw. Ay, si 3 kanina, nagalaw mo na siya. Okay. And, ang pansin mo naman na 2 lang yung binago mo, tapos 2 lang din nagbago. Ibig sabihin, 2 is disconnected from the others. Okay. By chance, no, may ibang group isang letter, isang button lang pinili nila. Sabi nila button 1. Button 1 lang. And it turns out ito lang yung ma-produce mo. Swerte. Pero may ibang buttons na kuwari 005. It's also strategic pero baka malito kayo. 0000. Ay, mali. 001 1. Okay. So, ito yung lumalabas sa 5. Okay. So, mas madali ito kaysa dun sa safe charger. Kabit ka lang ng kabit dito eh. With, Then, kayong bahala sa design nung circuit. Ang mahalaga lang, may switch ka dapat na in-implement dun sa source mo. Okay guys, so akala ko gets nyo na yung diode pa lang sa activity sa safe charger kasi pinost ko naman lahat ng circuit diagram, yung code, and napansin nyo naman yung code para wala naman binago, blink lang din yan. Okay, sir, paano po ulit naging 5 sa cathode ng LED 5 sa config 3? Config 3. 3, 4, 5. Ito, 3, 4, 5. 3, 4, 5. Sa cathode ng LED 5. Dahil may kinabit akong wire dito. May kinabit akong wire. So, 5 volts yung wire dito dahil wire lang din naman tong switch na to. Nakabit siya dito. Okay, so it would turn off this guy. And ang maganda sa design na to, it's safe to do this. Kasi, saan pupunta yung 5 volts mo? Madidissipate siya no last resistor. Okay, any questions? Any questions? So itong mga itong mga ginagawa natin from the previous activities, ginagamit siya for the next activity, no? So yung activity 2, yung blink natin, yung paggamit ng LED, definitely gagamitin siya sa susunod na experiment. And ayun nga, ginamit siya sa design experiment. Tapos, okay. Parang walang nag-aral sa inyo nung implications ng mga bagay-bagay. Anyway, that's it for this circuit, no? Akala ko tinry nyo yung safe charger. Tapos nagets nyo na paano magpatay ng diode. Okay, so again, pag less than yung nandun sa kabila, sa negative terminal, bubukas siya. As simple as that. Kapag mas malaki dun sa kabila, mamamatay siya. So itong idea na to, gagamitin mo siya sa mga susunod na mga experiment. So marami pang purpose tong mga diodes mo. Mayroon tayong tinatawag na peak detector. So basically, kapag na-exceed niya yung kapag if you have some noisy source VM na lang. Noisy source. Pero nagtatransmit ito ng data na alam mong nasa 6 volts yung kailangan mo. Pero it ranges from 0 to 6 dahil nga noisy siya. So, pwede mo lagyan ng diode. Tapos, pa-plug inan mo to ng, alam mo na greater than 6 volts yung kailangan mo, lagyan mo siya ng 5.5. So, every time na this guy is ano yung symbol na AC source? May ganun ata yung symbol na AC source. Every time na mag-exit siya ng 5.5, malalaman mo may dumaloy na signal. May peak ka na current. Okay, so marami siyang use. Hindi lang pampailaw tong LED, no? Hindi lang pampailaw tong LED. Okay, sir, hindi po namin agad paano i-apply kapag isa lang yung source. Pag dalawa po ata, yung nasa safe side. Ha? Hindi ba mas madali pag isang source lang? Guys, pwede kayo magkaroon ng infinite, no? Ng infinite wars. Magkakaroon kayo ng 5, 5, 5. Di ba yun yung implication ng wars? Okay. So more than two sources ito, and have as much as you want. Okay, and then yung voltage divider relations mo would also give you a lot of choices to have. Okay. So ayan. So bawi sa next lab activity, no? Mag-tinker na kayo ng ano. So yung mga groupmates, dapat nag-iisip din sila na kung paano ba yung mga bagay-bagay. Para hindi lang yung leader na hihirapan bumuo ng circuits. Okay guys, so ina-assume ko na, no, marunong na kayo mag-LED. Marunong na kayo mag-LED. Yes, related lahat ng activity. So lahat ng skills na nakukuha sa una, so gagamitin sa susunod. Hindi yung pasok sa kabilang tenga, labas sa kabilang tenga. Okay? Tungkol saan yung next? Wala pa. Iisip ko pa kung magpo-proceed ako sa normal course nung experiments. Okay, anong use nitong may natanong sa atin? Good question. So, breakdown ko muna yung circuit ko, no? Okay, tapos switch, resistor, LED, resistor, tapos ground. Okay, in essence, ganito yung itsura ng circuit. I-close natin for now para mas madali magkaroon ng intuition. Okay, anong sense nitong resistor na to? Safety. Kasi if I want to, so ito ay sabihin natin 5 volts. So this guys, okay, for this guy, meron siyang 5 volts, less than 5 volts, less than 5 volts, and then this one is 0. Okay. If I were to remove this resistor, I were to remove that resistor, ang mangyayari is that wire lang to, and this is also 0. Okay? And if I want to turn this diode off, magkakabit ako ng extra wire, di ba? Magkakabit ako ng extra wire connecting from here to here. And what happens? This is a short circuit. It's a short circuit. Okay? So kung mas mataas na voltage yung ginamit nyo sa Arduino, it will probably fry your Arduino. Wala namang masusugatan sa inyo, no? Pero wala, meron na kayo sirang Arduino. Sayang pera. Okay. So it's nice to have this resistor here so that your circuits would be safe. And this doesn't affect naman your LED. It won't lessen the light coming out of the LED. Kasi yung LED, nakadepende siya dun sa voltages applied. Okay, any more questions? Any more questions? Sir, pwede po ba mag-request ng extra credit activities for lab and leg? Hindi, bawi kayo sa lab. Bumawi kayo sa lab. Magbibigay na lang ako ng bonus sa lab. Sanay tayo sa asynchronous na ano. So, 3 hours lang yung lab, no? More than enough time siya. More than enough time. Tapos, guys, may mga hindi napapagana yung LED, tapos hindi naman nagtatanong. Okay, tutulungan ko kayo mag-troubleshoot, no? Tutulungan ko kayo mag-troubleshoot. So, lahat ng questions yung regarding that, sir, bakit hindi umiilaw? Sir, bakit mahina ilaw? Masasagot natin lahat yan. So, don't waste your time just trying to solve it on your own. Basta hindi regarding do sa problem that we have, any other problems, tutuganan natin yan. Magtatanong kayo. Hindi yung, sir, hindi po na yung pagano. Tawagin na lang namin kayo. Okay. Kaya nga ako nag-ikot-ikot sa mga breakout rooms para masolve yung mga ganong problem, para hindi kayo na-stuck doon and wala kayo na proceed doon sa actual problem na kailangan nyo. Sir, bibigay niyo po ba yung exact circuit na nagawa niyo, sir, para sa last activity? Ito, yung ginawa ko. I think this is it eh. Hindi ko maalala. I think this is it. Okay, I think this is it. Ito na yun. By chance, no? Okay, again, meron kasi mga tao na, na hindi nila naiisip agad yung ganito, tapos mas naiisip nila sa circuit agad, So, iba naman, sanay dito sa isipin muna nila yung ganito before proceeding to the circuit. Okay. So, find out kung sino sa grupo nyo yung ganun, kung sino yung, then play with your strengths. Magaling ako mag-circuit diagram. Doon ako ako yung gagawa, sundan nyo to. Okay. And then yung iba naman, magaling sila gumawa talaga ng may engineering skills sila. So, mas nai-imagine nila yung circuit by doing it by hand. Okay. Okay. So, anything else? Anything else? Okay. Wala naman na. Ayan. Oh, sir, wala naman po bagong materials kailangan. Next experiment. Magpo-post ako. Okay? Magpo-post ako. Probably bukas or today. May proper way ba to turn off? May proper way ba? Good question. Proper way ba to turn off yung Arduino after using? Okay lang po ba yung dinidisconnect lang po bigla? Yes, okay lang yung dinidisconnect bigla. May regulators ng voltage yung Arduino. So, basta galing siya sa USB, okay lang yun. And mababa yung, pag kinabit mo siya sa battery, okay lang din, basta mababa yung battery mo. Pero a safe way to do things like that, sige, drawing natin. Okay, hindi na pala. A safe way to do things like that is that pag hinugot niyo yung USB, hawakan niyo yung bakal ng USB para sa inyo dumaloy yung kuryente. Okay, kung medyo praning kayo na gusto nyong safe yung Arduino niyo. Pero kasi yung Arduino natin, pag nasira mo siya, if by any case nasira mo siya, yung microcontroller niya, yung CPU niya, is somewhere here. Natatanggal yan. Natatanggal yung malaking transistor na yan. So, re-replace mo lang siya, then you have your own bagong Arduino. Unless na lang yung masira mo ay yung pin, which is na-burn mo yung pin. Ayun. Medyo masisira yung pin pero usable pa rin yung ibang pin. Okay lang. So, mga gamit mo pa rin. Kaya rin maraming digital pins ito. So that may extra pins ka to use. Pero probably hindi naman natin masisira yun unless you do something unusual. Okay, any more question? Okay. Again, libre mag-consult. Kung nagtatry-try lang kayo ng mga circuit, lalo na sa mga leaders, no? Open source yung Arduino, so marami kayong makikitang experiment online na kung gusto nyo gawin. Tapos hindi nyo mapagana, okay, just message me. Libre mag-consult. Okay, so sige, wala na.